And as we're going to see when we speak in a couple later on, the AMP capability provides point-in-time malware detection and blocking through sandboxing, and also provides continuous analysis and retrospective security. I'm going to get into more details in here when we go to the sandboxing, let's say, definition and what sandboxing does. But before we go there, as I said before, because Cisco's AMP, so you can deploy Cisco AMP on both the email security appliance, which means, you know, all mail traffic is going to be inspected, all the files are going to be inspected, sandboxed through the cloud, or also we have that capability on the web security appliance. We have that capability also on the Firewall module. And we have that capability also on the endpoint. Now I'm going to speak a bit more on the endpoint when we go to the sandboxing capabilities and limitations. I'm going to speak more about the endpoint. Why would you deploy AMP on the endpoint when you get there? But before that, let's speak why would you deploy, you know, at the same time AMP on one or more of those three security devices, so like on the ASA, on the WSA, or on the Firepower. So before ASA with Firepower services supported on-the-box decryption, it meant that, for example, let's speak about email. So let's look at the email traffic in an enterprise, how it works. So the user PCA would send an email, let's say, to its internal mail server, which would be the Exchange, let's say. So this would be the Exchange server, Exchange. And that session is usually encrypted. Of course, it could be the other way around, but in general it is encrypted. So clearly the DSA firewall says nothing in there on what the user sent out in the network. What was the content of the email in there? Then the Exchange server, because this is only, you know, provides mailbox, let's say, storage and basic rules of who can send mail to who in the company. Then the Exchange server is gonna relay that message towards, let's say, the email security appliance, which this would be the publicly available SMTP gateway used to send mail traffic back and forth from the internet. So then the Exchange server would send this traffic out to the email security appliance, likewise through this time via SMTP, which of course could be configured to use TLS, which means again DSA firewall says nothing else but, you know, an SMTP session, but says nothing within the content, cannot inspect the traffic at all. And then of course the email security appliance, given that, let's say, the mail that Christian has sent out on the internet meets the security policies, then email security appliance is going to send the mail out on the internet towards the destination using again SMTP, and clearly of course using likewise maybe TLS as well. So as you can see in the whole traffic flow, the DSA firewall could never ever see and do the packet inspection on that session because all traffic was encrypted back and forth. So at this point you would need to go on the email security appliance and activate AMP capabilities, because the only devices in the network that see the mail traffic in clear text are the user, the PC that sends the traffic in the network. So the only devices that see can do deep packet inspection on the attachment are going to be the sender, the PC, are going to be the Exchange server, because the Exchange server terminates the session from the user and then starts a new SMTP session to the email security appliance, and of course the email security appliance. So those are the only three places in the network where you could deploy sandboxing or AMP to see if the content sent out on the internet, or of course also received from the internet, mail received from the internet, it is malware or not. So in that use case, you would want to go on the email security appliance and enable and license the AMP capability. Of course, even let's say with the new codes where the ASA firewall, the ASA with firepower services supports SSL decryption, you may still not want to do it at the ASA. So you may not want to activate the AMP license on the ASA in there for a couple of reasons. Maybe for performance, that would be one thing, because key decryption is going to lower down the performance, or because you don't have, or because in your case you do AMP on the endpoints and on the web security appliance and on the email security appliance, which pretty much means that as long as you control that all traffic being sent back and forth to the ASA is only mail and web, and then whatever is mail and web is going to be controlled by the email security appliance and by the web security appliance, then you don't need AMP activated also on the ASA. So it is based on based on design, custom requirements, because some customers may want to have a sandboxing at the mail server level, at the proxy web proxy level. So it depends on the design, on the custom requirements, and also on the performance requirements, because maybe that ASA it's a lower a lower box with not too many performances, and enabling encryption could create a bottleneck. The same thing goes for web. So why would you enable AMP on the web security appliance? Likewise, if Christian wants to go out on the internet, he would send traffic. Somehow the traffic would be received by the web security appliance, the proxy, which controls web traffic back and forth to and from the internet. So what that means is that as Christian sends traffic, web traffic out on the internet, if it's HTTPS, it is going to create an HTTPS session with the web security appliance. So web security appliance can do decryption in order to do DPI. And then web security appliance, if the traffic is allowed based on configured policies, then web security appliance is going to initiate a new HTTPS session out on the internet. So likewise, at this point, the ASA is blind, sees only encrypted traffic. As I was saying, even if it has decryption enabled, maybe that's not what you desire for a lot of reasons, as spoke before. So at that point, likewise, you would want to go on the web security appliance and activate AMP capabilities. So it's all based on designs. Clearly, it doesn't make sense to have in your network AMP activated on both the web security appliance, on the email security appliance, and on the ASA, just again for web traffic and for email traffic. It doesn't make sense, because all queries in the end go out in the same location in Cisco's cloud. It does make sense to do it at both mail security appliance level and email security appliance level, and also at the ASA with firepower services level, but for different services. So on the web appliance, you do it for web traffic. On mail appliance, you do it for mail traffic. You inspect only that kind of traffic. And then on the ASA, maybe because you allow traffic back and forth to and from the internet, also other kind of traffic, except web and mail, and you may want to inspect that traffic in there as well. It's long discussions based on designer requirements, but you could do whatever in the end to meet customer requirements. Okay. Now in here, I used a Firewall threat defense name, but I'm not referring to let's say Cisco's new unified code, but I'm referring in here to Firepower services threat defense capabilities. So I'm not speaking about the unified code, but just the regular ASA with Firepower services, and how that does threat defense in the network. So when Cisco acquired SourceFire, they clearly like their, let's say, vision of protecting the customer, which basically what that means is that it provides security through the attack continuum. Because as I was saying before, we have to accept the fact that sooner or later everyone gets compromised, gets hacked, gets attacked sooner or later. So you would need to be able to provide security before the attack, so some measures to prevent the attack from happening. Some measures to detect an attack, so while the attack happens, and of course if you got compromised, you'd want to be able to quickly identify that up and quarantine the infected endpoints and provide remediation, so after the attack has happened. So before the attack, we control traffic, we secure, let's say, the network via, as we said before, via regular access firewall rules based on IPs, based on usernames, identity firewall based on SGT tags, based on VPN rules. So we have some kind of control of who goes where. Then, speaking about the internet, we control access out on the internet and what we get from the internet through application inspection and reputation-based URL filtering. And of course, we do a base initial set of restrictions. Because clearly doing that also with the application level will restrict traffic to certain applications. When we have URL filtering, we do a further better restriction towards sites which are known as to host malware, or also to sites which don't meet our internal security policies. But then, of course, some traffic has to be allowed back and forth from the internet, which means at that point, throughout that session, back and forth, we can get malware or we can get infection. So during the attack, we have the next generation IPS part, which does both signature-based and abnormal detection of traffic back and forth, and we have AMP and sandboxing to be able to detect if whatever we get from the internet is malware, a known malware, or unknown malware, and of course drop the session. And of course, we have web traffic inspection, the dynamically based on web traffic inspection, which URL filtering is going to do only initial restriction to say who gets access to whatever destinations. But then, as web traffic goes back and forward, we have to inspect the web traffic and do AMP and sandboxing for the payload. And of course, in the end, still, we may still get infected, so we have to be protected also after the attack has happened. And we'll speak in a couple later on how that works. That how does AMP through what is called retrospective security, how does it, let's say, allow for you as the security, let's say, department to be able to identify that a host got compromised with something which was completely unknown, and to quickly quarantine and remediate that. And of course, you will also want to we're going to speak about what is the indication of compromise and incident response, because clearly you would want to not only to be alerted that like back in the days that IP 111 got infected, but you'd want to know for real how the attack has happened, from where did it came from, what are the targets, what are the victims, if the infection has spread to other endpoints in the network. So that's going to be a detailed report of what is the current state of the network, so you know what actions you have to take further on to avoid total compromise and to avoid total data loss from the network. Okay, let's see if there are questions before we go to another topic. There's a question from Neil which says, "Do you happen to know what a performance hits on the CPU if you do SSL decryption?" So I have a for Firepower 6.0, which supports SSL decryption. I had a document at that point. I'm gonna look it up. Cisco has done some kind of performance testing back and forth to see not exactly what's the impact on the CPU, but to see what is the performance. How much traffic can you send back and forth with decryption activated, and of course with other features activated. A question from user: Does the Firepower do the same functions of a web security appliance? No, the Firepower supports. So the web security appliance, from the security point of view, let's say we have URL filtering on both the Firepower and a web security appliance. We have AMP on both the Firepower and a web security appliance. What else? We don't have what Firepower doesn't have is the built-in anti-malware antivirus engines, which the web security appliance has, like the McAfee part, the Sophos part, the whatever other, because we used to support three vendors in there. So WSA has also additional, classical, malware and antivirus engines in there, which the Firepower doesn't have. And of course, the WSA has it is a true web proxy. The Firepower is not a true web proxy. Firepower is going to, intercept the session just to clean it up and to make sure that, traffic is allowed per the internal policies and traffic is clean back and forth. But if you want a enterprise level proxy service, with authentications, with port redirections, with a complex set of policies back and forth, the web security appliance is the way to go. So again, it depends what you want to achieve. Even though the Firepower and the web security appliance have a couple of overlapping features back and forth, the web security appliance is a better with much more capabilities and features from the web inspection point of view as opposed to Firepower. Likewise, the application visibility control and support is pretty much the same, so both of them support that. But let's say the WSA still has, let's say, a better enterprise integration from that point of view as opposed to the Firepower at this point. Question from Kusai: How does ASA with Firepower stack against other firewall from other vendors? So clearly from that point of view, I can only show you a Gartner report. So let me bring that up. I think it is from NSS Labs. I'm not 100% sure. Should be, because pretty much NSS Labs next generation firewall tests 2016. Okay. So let's look up again NSS Labs. NSS Labs Firewall 2016. Okay, looks that I have a problem with the zooming function, so I'm just gonna zoom another way around. So if you look it up, it's interesting in here. Like the way you read this table in here is that the what is the top most right one, it is clearly like, for example, left to right. So as you go on the vertical, it is more secure. So as you go up, it is more secure. And as you go left to right, it is better cost. So cheaper, that means cheaper. Which what that means is that based on this on that aspect, Hillstone and Huawei scored, best from the security. Hillstone scored best from both security point of view and SCAS point of view. Then Fortinet Checkpoint seemed to be securing there, securer than Cisco, and Cisco is kind of like in here with the firepower. So it's not doesn't provide the best security out there, doesn't provide the, let's say, the cheapest, let's say, firewall or per megabyte in there, but this is not a accurate one from my point of view for a couple of reasons. So first of all, and this is very important in general, because nowadays, and that is a good thing on Cisco, so if you want to actually provide to a customer security nowadays, okay, we have an next-generation firewall which does a lot of things back and forth, but in the end, to be able to secure the network, we need to build a security architecture. So we need somebody to detect, bad things in the network, and somebody else to be able to fix those bad things in the network, and somebody else to, quarantine quickly the users as they get access in the network and they get infected. And Cisco has that whole security approach. Cisco has nowadays all of the core products to build their real security architecture. Because as I was saying before, there's no way that a firewall is going to catch 100% or not even close to that of the known attacks. What about the unknown attacks? So you actually need to build a security architecture where the network can defend itself and identify by itself when something went wrong in the network after the traffic has passed through the firewall and all of the inspections which are out there. So from my point of view, this doesn't mean in here that the Hillstone or Huawei is the best product you can buy out there and then the customer is secure. You have to think big, you have to think better, you have to think in the architecture point of view. So since we're here, what Cisco does in here is very simple. So and then we move on. So let's say, as I was saying, traffic goes to the firewall in here, to the internet, and the firewall doesn't detect there is a known malware or whatever, but still the user gets infected in there. So number one thing, you need something else to be able to detect that that endpoint is infected with something which was unknown, which Cisco does that through the AMP on the endpoint and through LAN cope. So those two, let's say, capabilities are going to detect when an endpoint, got infected, or an endpoint, got infected with something unknown, but still, speaks to the command and control center. Because clearly you may not detect that new malware, but you may detect easily that, when that PC which got infected speaks out to a command and control center, which means clearly the endpoint is infected, right? Or we're speaking a couple of minutes about sandboxing. So you need something to be smarter in the network to detect if a network got infected with unknown malware as fast as possible. And once you have identified that up, you need to take action. And that doesn't mean remediation. Second thing, you need to do quarantine. You need to quarantine infected endpoints and do that automatically. Like, for example, imagine this happens, it usually happens at 2 a.m. You forgot a laptop open in the network, it's 2 a.m. and you get infected. By the time you get an email and it's 9 a.m. in the morning to get to the office and quarantine the endpoint, it's too late. It's 7 hours past, it's a huge amount of time. So you want this to be automatically performed. As somebody detected AMP or LAN code that, an endpoint might be infected or it is infected, you might want somebody else to trigger an instant action to quarantine the endpoint. And this is going to be by integrating Firepower or web security appliance or for example, it's the web security appliance or ICE. Because as long as you understand that ICE control the access to the network, then ICE can as well, deny access to the network to an infected endpoint. And only then, third, you perform remediation. Which this means you can do that, at 9 a.m. in the morning, because the network has by itself recovered and taken action automatically to quarantine the endpoint. So you can go in the morning and then you're relaxed and then take action to remediate. And you know what to remediate, because you're going to have from the firewall the incident indication of compromised and the reports for the incident report. You know exactly who was speaking with who got infected, and you know what to clean up. So again, it doesn't mean that, looking in here in this case is that, okay, Cisco is not good, I'm not going to buy Cisco. Actually, I would say that Cisco has a very good vision moving forward, and they have a strong, they are powerful, and they have a strong products which make a good security architecture in the end. Having a single product which does a lot of things, protects you at a single point in time, one time, if they can detect the threat. But otherwise, after that, you need other capabilities in the network, which that means a security architecture, which Cisco has it. Other vendors, they don't have it, because they don't have those products back and forth. But still, speaking from the next generation firewall point of view, I would say that Cisco would be clearly better somewhere in here or whatever, way better up. The problem is that in this test, they haven't used the new version, their new hardware platforms, which other vendors have used. So like if you look on one, always when you read the document, look in there on what they used. Because let me look at the proper one on the NSS Labs webpage. Hopefully it's not going to block again. So they said in here that Fortinet has used what? Fortinet has used FortiGate 3200D, which not 2014 but 2016 I'm looking for. Okay, let me give it one more try with this one on NSS Labs. Yeah, it's I'm not going to spend any more time in here, but basically other vendors like Fortinet, Chip and whatever have joined that specific test. You can look up on the report. They joined the test with better hardware, while Cisco didn't join the test with the new hardware, the new 9300 or the new 4100 boxes, which not only they provide a better cost per megabit performance, so better cost, but also they have added capabilities which other hardwares that they don't have it built in. So if Cisco would have joined with the newer products, they would have clearly been way more better. Why not maybe tops number one? So when you read a document like that, again, it doesn't mean look on which vendor with which appliances has joined the test to understand if it's relevant or not. And second, you should always think bigger. That nowadays having a UTM or next generation firewall in place, it's not enough anymore. You need much more than that added, as I said before, and Cisco has those in there built in, and they work beautifully behind the scenes. They do a good job basically. Okay. Yeah, sir, question: what's the difference in using SDM and Fireside for the management of the firepower? We're going to speak when we get there. As basically at this point, SDM has a couple of less features. We're going to speak when we get to that point. And of course, the main difference being that SDM being built in, you can manage less devices, less firepower devices, than by using the Fireside Management Center. Okay. A question from Kusai: what I say iOS is needed to support Firepower? It really depends on which Firepower version you run. So when you get there, I'm going to show you in the release notes. Again, that kind of information, I highly discourage you to memorize. Remember, it's useless data. For that reason, you have release notes. If you know you have to deploy to a customer specific feature, you look in the release notes, you look on which specific version of Firepower that feature is supported. Then you look on the release notes also in there to find out what is the required code version of DSA to support that version. Always do like that. Never memorize useless data like release notes. That's I mean, it's useless. How could you keep track of thousands and thousands of release notes and versions? You just have to know what are the technologies, the options, how they work, how to build them, which ones to recommend, where and why.